The November 2025 exam prediction is finally here. This question paper is an exemplar and has questions that are guaranteed to be in your exam on the 31st of October. I'll jump directly to question 1 so that we can see what is expected. As you should know by now, from practicing in the beginning of the year to date, you would notice that the structure of the question paper is always the same, wherein question 1 will always be asking questions around algebra. So here we'll be solving for the variable x or any unknown variable using various methods. So our question 1 says to us that 1.1, we should solve for x. Now they say here that under 1.1.1, so we are doing question 1, we're looking at 1.1, and under 1.1.1, we are given an equation here, which is a quadratic equation defined by negative 2x squared minus 4x plus 70 is equals to 0. Now, traditionally, when you have a quadratic equation that has a negative number here or even a number here, you would want to attempt to remove this number. And to do that, you can take it out as a common factor, or you can divide by it throughout. So here, in this specific question, I can see that the 2 is actually divisible to a 4 and a 70. So I'm going to divide here by the negative 2. So that my equation now reduces to x squared, because negative 2 divided by negative 2 is just a 1. And here I'm going to have a positive 2x, because the negative and the negative will be positive, and 2 goes twice in 4. And then we're going to have a negative here, because the positive and the negative would give me a negative, and obviously half of 70 should be indeed the 35. And this is equals to 0. At this stage, this looks like something that I can factorize. So I know that here I'm going to have my first terms to be an x and an x, because when I multiply these two, I get an x squared. Now the shortcut that we're going to use here is that I'm going to look for the factors of 35, which for me what comes to mind is actually a 5 times a 7, because these two, they actually give me the 35. But now what I need to do is that when I combine these two, either by adding or subtracting them, I should get a positive 2 here. Now when I look at these two multiples, I can see that for me to get a 2 here, a positive 2 here, I actually can say that I have a 7 minus a 5, because 7 minus 5 will give me a 2. So this is the 2 here, and that would mean that my 5 should be negative 5 and the 7 here should be a positive 7. And now all this will still be equal to 0. And as a result, this would mean that my values of x will be equals to a 5, or x should be equals to a negative 7. Now, we call these two numbers that are found here the roots of the equation that we are given here at the top, or we call them the solution of this equation. What that means is that if I take this 5 and substitute it here on x, I should get a 0 this side. So that would mean that the left-hand side will be equal to the right-hand side. Both of them will be 0 if we put this solution or the root of this equation. The same is true if I use the negative 7 and put it here. I should also get a 0. And we then say, if the right-hand side and the left-hand side are equal, we then say that these two roots or solutions, they actually satisfy this equation. In other words, they make the equation to be true. Very important to remember those basics. Now the next question, okay, before I jump to the next question, it is very important to also learn what actually is going to be marked here. We are going to get 1 mark for doing correct factorization and get 1 mark for getting the correct, and 1 mark for each correct answer, then the final answer here. And that's how you get a total of 3 marks. The next question, which is 9x 1.1.2, it says here that we are given 1.1.2. It says we are given here 9x squared plus x is equals to -3. And we are told here that we must correct to 2 decimal places. Now, this is a hint to say we need to use a quadratic formula. So before we can even get to a point where we use quadratic formula, it is essential for us to put this equation in a standard form. So that would mean that taking the -3 to come to this side, so that I have now 9x squared plus x plus 3 is equals to 0. Remember, the 3 will be positive when it comes to this side. Now at this stage, I can quickly and directly go to my quadratic formula. Now, one may ask to say, we have a number here, why can't we divide with that number? Well, if you see here, there are no factors here. It's 1 and it's a 3 here. 9 doesn't really give us a good number when we divide it by 1. It's not going to, it is not divisible to 1. So that's why here we can directly and quickly go to a quadratic formula. I'm just going to write my quadratic formula in full here, just so for us to remember this formula. And I must tell you that this formula is there on the formula sheet. In case you forgot this formula, you can go there and use it directly from the formula sheet. Now, after writing this formula down, what you then do here, you then substitute. So the b here, we all know that is going to be the coefficient of x, which is 1. So that means we're going to have a -1 plus or minus. Here I'm going to have 1 squared minus 4. And the a here is a 9. So we're going to have a 9 here times, and our c really is the 4 there. We're going to multiply this by a 4. And all this is going to be 2 times the 9, which is the a. Okay, I would love to simplify this a bit before I can go to my calculator. So this would be 1 plus or minus. 1 squared is just the 1. We know that 4 times 9 is 36. 36 times 3, that should be 108. So we're going to have a -108, and all this is equals to 2 times 9, which is just an 18. And if I go a little bit further, I can see that here I'm going to have -107 divided by 18. Now at this stage, we can see that our discriminant, if you look at the number here, we call it the discriminant, is less than 0, meaning it is negative. So if it is negative, it means the solutions or the roots that we're going to get for this equation are really non-real numbers, right? They are real non-real numbers. They do not fall in the real number system. So it means here we're going to say this would imply, this implies that we have non-real roots, and that's where we're going to leave our answer, because we can't define these numbers. We don't use the real number system. Had it been that we use the real number system, we can go solve this using the real number system. But in our CAP syllabus, we don't work with non-real number systems. We only work with real number systems. So the solutions that are possible for this question, we are not going to solve them as part of our syllabus. We'll leave the answer there. So now this question was also for 3 marks. That means we're going to get a mark Firstly, for writing this in a standard form, that's very important because we've written this in a standard form of ax squared plus bx plus c. Then the second mark that we're going to get is having a correct substitution and really coming to that conclusion to say we don't have real numbers here as solutions. We get non-real numbers. This is our discriminant is really less than 0. Now, the next question that we are going to look at is 1.1.3, which is given by the root of x plus 1 plus 2 is equals to 3 all over the root of x plus 1. Now, there are many ways of solving this problem. Some are long and tedious, some are easier than others. But I want to share the easiest method because remember, with an exam, you also have to be careful with the time. The easiest and fastest way to solve this problem is to notice that the square root of x plus 1 appears here and it also appears on the right hand side as well. It's exactly the same type of expression. So that means what I can do, I can then come and say let a, I'll use the letter a here, you can use any letter, let a be equals to x plus 1. Because then now I'm going to then substitute a every time I see the root of x plus 1. So this means now here we're going to have a plus a 2 is equals to 3 all over an a. Now when you are at this stage, this question will be really sweet. You'll get to enjoy this question. Now at this stage, what I'm going to do is that I'm going to multiply both sides by the a and also multiply here by the a. It is very important to put brackets this side when you multiply by the a. So on this side, a will multiply this one, I'm going to have an a squared, and a will multiply the 2, I'm going to have a 2a. So here I'm going to have a squared plus 2a, but this side, you must notice that the a would actually cancel each other, and I'm going to have only a 3 left on that side. As usual, you'd want to write this in a standard form. I'm going to take the 3 to the left hand side so that I have a 2a minus 3 is equals to the 0 then. Now we have our standard form. And this looks like something that is very easy to actually factorize because then I'm going to have an a and a this side. And I can see that the factors that will give me a 3, the factors of 3 here, is a 3 and a 1, isn't it? So 3 times 1 should give me the 3. So this 3 here is the 3 here. But I want to have a positive 2 here. I want to have a positive 2. For me to have a positive 2, I can see that when I combine the 2, I'm going to have my 3 to be positive and my 1 to be negative. Because if you say 3 minus 1, you actually get a positive 2. And this works really well because if I multiply these two numbers, I will then get the negative 3 there. So this means my factors here will really be a negative 1 and a positive 3. A is equals to 1 or a is equals to negative 3. Now at this stage, I'll then go back and bring what a is. So I'm going to bring that back to say here I'm having x plus 1 is equals to a 1. Or I'm going to have root of x plus 1 is equals to negative 3. Now before I go any further, I just want to focus on this side here to say we know from our knowledge of mathematics that it is not possible to take a square root and get a negative number. So what that means is that, if you want to save time, you can immediately reject this answer because it's not going to be a correct one anyway if you continue with it. So we'll say that this is inadmissible. This is inadmissible, meaning we can't accept this argument. It doesn't make sense. You can't take a square root and it gives you a negative number. So it means our focus will be only on this side. Now when we are here, I will then square both sides. That means I'm going to put a square root on the left hand side and a square root on the right hand side. Now this side I'm only going to be left with x plus 1, and this side I'm going to have a 1, because 1 squared is just a 1. Now this would then mean that now x is indeed equals to a 0. But now when you are at this stage, it is very important to really check this answer. We call it a root or a solution again, to see if it satisfies our original equation. You must check and see that it makes our equation, it makes the left hand side to be equal to the right hand side. So that means I'm going to take this value of x0 and substitute it where I see an x, and get the number this side, and also do the same on the right hand side. If both these two sides, the left hand side is equals to the right hand side, then that answer will be accepted as a solution or the root. You can do it without a calculator. One would see very quickly that when we put 0 here, we're going to have a 0 plus 1, and the root of, and 0 plus 1 is actually 1, and the root of 1 is just 1. So this side I'm having a 1 plus a 2, which will then give me 3. So on the left hand side we have a 3. Now this side we put a 0 here, I'm going to have a 0 plus 1, and this will just reduce down to 1. So it means I'm having a root of 1. The root of 1 will give me a 1. So I'm having a 3 divided by 1 at the end of the day, and it gives me a 3. Can you see that now the left hand side is the same as the right hand side, because both of them are equals to a 3. So this means this number is a root or a solution to that equation. It satisfies that equation. It makes it to be true. So we're going to accept that as an answer. Now this question is usually out of 5 marks, but let us see where does the 5 marks really comes from. So you will get your first mark by really setting up a to be equals to root of a plus 1 and substituting that so that the equation reduces down to that. And you will also get another mark for writing down your standard form of a quadratic and factorizing that standard form. Then the other mark will really come from squaring both sides here. And your last mark actually comes from the final answer, which will include you rejecting the other side. So the 0 plus rejecting the other side, that will give you another mark. And that should be a total of 5 marks. Now, you would know by now that there's a culture that we will get a question that looks at inequalities, which is question 1.1.4 in this case. And what this question says to us is that we have x squared being greater or equals to negative 2x negative 1. Now the first thing that we do here again is to write this in a standard form. That would mean that I'm going to take the 2 negative 2x and the 1 to the other side so that they come in to the left hand side. Now I'm going to have an x squared plus 2x plus 1 being greater or equal to 0. And that is our standard form. Now, this statement also is very important to also analyze or understand what it means. So what this statement means is that if we have a function or a parabola that looks like this, or this expression, if it's given by this, we are going to look for the values of this expression or this parabola where it is 0, meaning equal to 0, or where it is greater than 0. Now, to say something is greater than 0, it means it's positive. So we are going to look at the values of x that are either 0 or positive. That's what we're trying to look for here. Now, when it's like this, it is best to factorize this so that we can find the critical values. So here I'm going to have an x and an x, and I can see that my factors here is 1 and a 1. When you multiply 1 and a 1, you get a 1 there. And if you say 1 plus 1, you get a 2. So that means both of them are positive. And this would mean that my critical values, CV, will then be equal to, so the critical values occur when these products are equal to 0. When these two are equal to 0, so that means my critical values will be -1 and -1. So they occur twice. I have -1 and -1 occurring twice. Now I'm going to use these critical values to then construct intervals. So I'm going to have an interval here of -1. Remember, I have the same roots, or I have the same critical values. So that means they will be both mapped there. Then I then now have two intervals. One interval where x is less or equal to -1, and the other one where x is less or greater, where is greater or equal to -1. Now what we do here is that we then test these two intervals to see that if we test them, if we take any number on this interval and take any number on this interval, do we get a positive values of x? Then the ones that are positive will be the one that will satisfy this equation, or this inequality, that will make this inequality to be true. So to do that, I'm going to use this part of the inequality and put values that are smaller than -1. So for instance, I can take -2, I can take -3, or any number really that is this side. So I'll firstly start by saying I'm having here a -2 squared plus 2 times -2 plus a 1. And I can see here that I get a positive number. So this interval, this means that in this interval, if you take any number here, -2, -3, -5 until -infinity, they are all going to give me a positive number here, right? Because there's an equal sign, it means if we take -1 here, because it is included, what do we get? We should get a 0 here if we have done everything correctly. But just to double check, I'm going to say if we have a -1 here, what do we get? Then we get a 0. So that means also this -1 is part of the solution. Now this side, I can take any other number here. I'll use a 2 is the closest. So this side we have a +2. And already you can see that I'm going to get a positive, because a parabola is symmetrical, because this is a parabola. It's symmetrical. So if I get a positive number when I use -2, I should get a positive number when I use a +2. And indeed, I get a positive number here because I have a +9. But remember, you don't only have to use -2 and a 2. You can still also use other numbers. So here we can use a 2, 3, 4, 5, 6 until we get to positive infinity. Now there's something very interesting happening here. All these numbers here, including -1, they satisfy this equation. In other words, they give us positive numbers and they also give us a 0. This means that our x is an element of real numbers. All the real numbers will make this inequality to be true. So now this question was out of 3 marks. Your first mark will really come from writing the standard form. Very important. And this is important because we actually even use it to do our intervals. And the other mark will come from factorizing and finding your critical values. That will be grouped to give you 1 mark. And the final answer the final mark will come from the final answer, meaning answering that your values of x are all the real numbers in this specific question. There are other ways in which one can write this. You can still say, my answer would be -infinity to infinity. So these are all real numbers, really. This will also give you a mark if you write it like that, and any other notations that you might know. The other question that is always guaranteed to be in your exam would be a simultaneous equation. As you can see here in question 1.2, they say here solve for x and y simultaneously. And we are given these two equations here. We are given that x times y, the product of x and y, is actually equals to 4. Immediately at this stage, I can decide to make either x or y subject of the formula. It's really up to you. I'll choose to make y subject of the formula so that I have 4 over x. So what I've done here is that I've divided by x and divided by x. The x and the x cancels, then I have that. Now at this stage, I'll then call this equation 1. Then the other equation that we are given really is this equation that says here we have a 2y plus x plus xy being equals to negative 2. I will immediately call this equation 2. Now you would see that, when you have a lot of practice and experience, you would see that I immediately made this equation 1. The reason being is because this one is too complicated. I'm not going to attempt to try to make x or y subject of the formula here, because it will work out if you do. You will get the correct answer if you do, but the problem is that it will be long. That means you'll waste a lot of time. And secondly, because it's too complicated, it will open up a lot of problems in terms of you making a lot of errors, in terms of your signs and your divisions and all that. So it could be very painful for you to try to make this the subject of the formula. So if you make this one the subject of the formula, you will get to enjoy this question. Now at this stage, what I'm going to do is that I will then say substitute equation 1 into equation 2, so that now my equation 2 will transform to be a 2. Remember, we have the y here, which is now going to be written in terms of x to be 4 over x. So this means here I'm going to have 4 over x. Then I'm having plus x. Then I have plus x times y again. Do you see that? Now our y would still be that 4 over x. And we are saying that this is equals to negative 2. Now, what I'm going to do then here now is to try to make it to be linear, is to remove these fractions here. So for me to do that, the first step will be perhaps multiplying this 2 and multiplying this x here so that it tries to simplify. So I'm going to have here not a 2, but I'm going to have a 2 times a 4, which is an 8. 2 times a 4 here is going to give me an 8. So I'm going to have an 8 over x plus x, and you would see here that the x and the x would cancel each other so that I have plus 4, and I can immediately take these 2 to this side so that it becomes a positive 2, and this is going to be equals to a 0. Now I still have a fraction here. I'm going to then multiply each term here by the x to try to remove this x. So this means I'm going to multiply by x, I'm going to multiply by x, I'm going to multiply by x, I'm going to also multiply this by x. And in fact, these two, because they are like terms, I can actually start by combining them so that I have a 6, and I have here an x, and then I have an 8 over x is equals to 0. Now I'm going to multiply by the x, as I was saying, for each term here, so that now I have an 8, I have x squared, x times x here would be an x squared, then I'm going to have a 6x is equals to 0. And I can write this in a standard form so that it is easy for me to then factorize going forward, or maybe use the quadratic formula. But I can see that this actually has factors. It's actually an easy product to deal with. The products of the factors of 8 would really be a 2 and a 4 would give me an 8. And here I have positive and a positive. So that means if I add the 2, if I say 4 plus a 2, 4 plus a 2, I should get an 8. So that means both of them are positive. So I'm going to have a positive 2, a positive 4. And this would then mean that my x should be equals to negative 2, or x should be equals to a negative 4. Now remember, what we have done so far is that we have only found the values of x. We still need to find the value of y. And already one can see how easy that would be. Because what I'm going to do now is that I'm going to say substitute x into equation 1. So I'm saying substitute these values of x into this equation 1. And so what this would transform to, or how it would look like, it will be y is equals to, remember, equation y is 1 is 4 over x. So we're saying y is equals to 4 over negative 2, because my first value of x is negative 2. Or we're going to have y is equals to 4 over negative 4. And this would simplify down to a negative 2, or y to be equals to a negative 1. Now, this would accumulate to 5 marks, and your 5 marks would be built up or come from firstly writing this equation 1, and secondly writing the standard form of the quadratic equation, factorizing that quadratic equation, finding the values of x, and also then finding the values of y. Both these values will give you 1 mark and 1 mark for that. The next question usually in this question paper would be questions that look at some questions that usually are tricky to work with, and can be difficult sometimes, but they cost very little marks. And I always advise that, with these questions, you can skip them and come to them when you have time, so that you can save time and don't waste time doing these questions. So let us look at what questions we have here. So in question 1.3, we are given we are told here actually that the quadratic equation x squared plus mx plus 8 is equals to 0 has one real rational root of 2. Then they say show that the other root is a whole number. Very interesting question. I think here we need to break down the language. So what we know here is that we are given a quadratic equation, and this quadratic equation has a root or a solution, which is a real rational root of 2. So this number here, it's a solution to this equation. That means if we put this number here, the x here, it will satisfy this equation. What does that mean? It will make the left-hand side to be equal to the right-hand side. So what we mean here is that if we put the 2 here and we find the value of this side, we should get a 0, just like the right-hand side. We are told that is a solution. But the interesting thing is that the question says to us, we must show that the other root, in other words, we must find the other root. Remember that the quadratic equation has 2 roots. So we must show that the other root of this equation is actually a whole number. And you must remember that whole numbers are actually numbers that start from 0, 1, 2, 3, and so on. They range from 0, 1, 2, 3 until infinity. So the other solution, the other value of x for this equation has to be any of these numbers here that I've listed. So the best way to begin this equation is to say that we are given the equation that says x squared plus mx plus 8 is actually equals to 0. Now we will say here that if one of the roots or the solutions is a 2, then this means that if we put the 2 back on that equation, if we put it back here on the equation, it should be equals to 0, because we are told that it's a root, it's a solution, it satisfies that equation. So this would be m2 and 8 is equals to 0. Now notice that when I do that, when I use that value of x that we're given, the solution to this equation, I am now able to find the value of m. And that will be really useful in our problem. So here I'm going to have a 4, I'm going to have a 2m, I'm going to have an 8 is equals to 0. Now the 4 and the 8 are like terms, and they will actually give me, so I'm going to have a 2m, and when you combine the two, they will actually give me a positive 12 is equals to 0. So this means I'm going to have 2m is equals to negative 12. When we take this 12 to this side, I'm going to divide both sides by the 2 here, and my m will be equals to a negative 6, because the 22 would cancel, and 2 into negative 12 is negative 6. So this means that my quadratic equation is actually going to be given by x squared minus 6x plus 8 is equals to 0. Do you see that? Because I know the value of m, I can then substitute that value of m. We're saying here that m is a 6, so I can put it back here, so that my equation becomes x squared negative 6x plus an 8. Now, when I have a quadratic equation like this, I can then find the two values of x. I can then find the two roots of x. And when I find those values of x here, one of those values should be the 2 that we were given, because already they've given us that root. So that means now here I'm going to factorize this, and I know that one of the roots is a 2, so I'm going to have a negative 2 there. And this side, I can figure that out. So obviously we're going to do this the traditional way by looking at the factors of 8, which I know one of it should be the 2 and a 4, because when you say 2 times 4, you actually get the 8. But when you say negative 2, negative 4, you then get a negative 6, which is what is here. So that means now our other root, or the other factor, should be x minus 4, and this is equals to 0. So this would then mean that we're going to have a 2, or we're going to have a 4. Remember that this guy already we know we were given, we're expecting this. So this was given, and this is the other root. So this is the other root, or the second root. But now remember, the question was saying that we have to prove that this root is actually a whole number. When you look at this number is here, is in the list of the whole numbers. So indeed 4 would be a whole number, and that's what we're required to show. There isn't much that we're doing here, so this question is worth 3 marks, and your very first mark really would come from finding the value of m, and the second mark will be you writing the quadratic equation, and indeed the final mark should be you finding x to be 4, answering the question to say the other root is a whole number. Now this one you're not going to really get a mark because you were given it as part of the question. Question 1.4 says to us that consider the expression. So they're saying to us, consider the expression 1 over the root of x plus 1 minus the root of n. Then they say here n is a positive real number. So now we are given, remember when they say consider, they really mean that look at what we have given you and try to make sense out of it, analyze it. And we're saying here that n is a positive real number. That means it's greater than 0. Remember, when you say something is greater than 0, it means it is positive. Now, there's something very interesting that you have to look at what we are given, the expression that we are given. This expression has a 1 here, simple to understand that. But there's a very interesting relationship between these two sets, or the roots, the square roots that we have. Under the square root here, I have a 1, an n plus 1. And here I only have an n. So that means this number here in the square root is 1 more than this one. It's bigger by 1 compared to the other one. That's very, very important to notice, And n is allowed to be any positive number. So it can be 1 over 2, it can be 0.2, it can be 1, it can be 5, as long as it is positive, right? And whatever number it is here, this side is one more. So now that's how I've considered this question, or what I've noticed. Now under question 4.1.1, they say here that show that this expression can be written as the sum of root of n plus 1 and root of n. Now remember, the sum, when we talk about the sum, we're talking about the number that you get after addition. So in other words, we want to say here that this can be the sum of this and that. Essentially, what we want to prove here is that we want to prove that this expression is the same as the root of n plus 1 plus the root of n, because the sum of root of n and root of n is actually adding these two, is a number that we get after adding these two. So here we're saying that we want to prove that this is the same as that. Interesting question. Now, there is a trick to do that. Move from here and to get to that, you have to rationalize this expression. So I'm going to write the word here, rationalization. We have to rationalize. So now to rationalize, I'm going to take my original expression 1 over root of n plus 1 minus root of n. And then I'm going to multiply this by the root of n plus 1 plus the root of n all over the root of n plus 1 plus the root of n. Now, you know, the method of rationalization is a method that I personally say that we do something but nothing. What do I mean? I mean that I've done something here, I've multiplied by this, but actually I haven't done anything, because these two, they cancel out and they give me a 1. You know, I've multiplied by the same numbers, denominator and numerator. So these two would cancel and give me 1. And if you say 1 times this whole thing, it actually looks the same, it hasn't changed. So I've done something but nothing. And I know somebody's asking there to say, how do I know that I have to multiply by root of n plus 1 plus root of n? Well, from the question itself, I have a hint. I'm trying to get to this part, so I've just multiplied by exactly the same thing on the numerator and denominator. That's how I chose how to multiply by that. And let's see where this will take me. Now, you can see that if you multiply this by a 1, I'm simply just going to have that, you know, the root of n plus 1 plus the root of n. But you would notice that when you multiply these two, they are actually a difference of 2 squares. You know, I have the same number here, then there's a negative, there's a positive. I have the same number here and I have the same number here. So that means I'm simply going to write this as n plus 1 minus n. Remember that the difference of 2 squares is given by a minus b, a plus b, and this should be equals to a squared minus b squared. That's exactly what I've done here. Now, when we simplify this further, we can see here that I'm having an n plus 1 plus the root of n all over. Now, look at this. The n minus n would just give me 0. Then I have a 1. In fact, I'll just stop here because, you know, 1 divided by the whole thing will just give me that. And in fact, I've just answered the question because I've proved that this expression can be written as the sum of these two numbers. And this is just 1 mark really, because there isn't much that you have done. You can do this within 1 minute. Now, the next question then says to us that hence calculate without the use of a calculator the approximate value of 1 over root 6 minus root 5, if we know that the root of 5 is given by that and the root of 6 is given by that. Now, this type of a question, I want to really break it down from how you should answer it. Immediately in mathematics, they use the word hence. They mean that you should use what you have done in the previous question. You should use the same method. And usually you should do a shortcut. You shouldn't start from the beginning. So hence means that. But also we are required here that we don't use a calculator and all that. Now, for us to get to a point where we don't have to use a calculator, we have to look at this expression that we're given and compare it to the previous expression. As I said, you can see that here inside the root, I have actually n plus 1 and I have a 6 here. And then here I have a 5 and here I have an n. You can see that 5 is 1 more than a 6. Do you see that? We have a 6, we have a 5. We have n plus 1, we have an n. You know, always this is 1 more than this one, 1 more than that one. So it means this expression has the same pattern as this expression. So that means for me to solve this question really, I'm going to be clever enough to say I see the same pattern as what we have done at the top. If I'm given 1 over root of 6 minus root of 5, this can be written as the root of 6 plus the root of 5, because I've proved it here from the previous question that you just add the two roots. You just add the two roots. So that means if you want to save time, you'll just jump straight to this because we have proved it in the previous question. That's why they say, or they use the word hence. So you can simply just jump to that part. Now, when we are at this part, this question becomes very, very, very boring. Why? Because now I have the sum of two numbers here, the root of 6 and the root of 5. And we are given their values here. So I'm given here that the root of 6 is actually 2.4494. Can we confirm that? Yes, that's the root of 6. It's given here, 2.4494. And the root of 5 is actually given as a 2.2360. Now we can add these things really without a calculator. If I have a 2.4.94 and I'm adding this to a 2.2360, we simply do the addition that we have learned in grade 1, where we say here that 4 plus a 0, it's a 4. 9 plus a 6 is a 15. So I'm going to have a 5 carry 1. So here I'm going to have a 5 plus a 3. That should be an 8. And we are also having here a 4 plus a 2, that should be a 6. Then we have our comma there, and then we have a 2 plus 2, which is a 4. So this means, you know, and the other thing that is very important is that this would be approximate numbers, because these numbers are, you know, estimates. They are rounded off, right? They are up to 4 decimal place. So this means now I'm going to have an approximate of 4.6854. But there's something very important here. Remember, normally we round off our answers to 2 decimal places. But this question has specifically requested that we round off the answer to the nearest whole number. So that means we must write this as the nearest whole number, as a single number. So this will be approximately, so you can see here that we have a 6, which is above 5. So it will throw a 1 here, and then we'll have approximately 5. Our answer will be approximately 5 as rounded off to the nearest whole number. And really, we mark here 1 mark, because you would notice that here I haven't done really much. I was taking the answer that I've done here, the pattern. I looked at the pattern of the previous question, so they really won't give you a mark for that. And adding these two is like grade 1 work, really. So the answer would be the one that is awarded if you get the correct answer. And that will be what I think you should be prepared for in terms of question 1. Go look at various ways of solving for x by factorizing, using the quadratic formula, squaring both sides, using an inequality, and then also be able to solve for 2 unknowns, that is solving for x and y simultaneously. And there will be a tricky question that will come your way.